Imagine, just for a second, that humanity simply vanishes. Whether it's from a sudden bioengineered superbug or some other rapid event, the world wouldn't actually stop immediately. Instead, for this brief, incredibly eerie window of time, our planet would basically hold a museum-quality replica of our lives. The coffee shops, the office buildings, our homes, they'd all just sit there, exactly as we left them, acting as a silent, immediate record of everything we built. It's a profoundly unsettling idea, right? But it is an absolutely fascinating one to explore.
Hello and welcome to this explainer. Today we're going to take a really grounded, chronological journey starting right from our potential vanishing point all the way into deep geological time. We're going to look at the actual data, the science, and the physics of exactly how the Earth would process our absence. It's a bit of a quiet eulogy for the Anthropocene, for sure, but as you'll see, it perfectly illustrates the sheer, unstoppable resilience of our planet.
Section 1. How we disappear. Loud endings versus the quiet extinction.
So, before we get into the aftermath itself, we kind of need to understand the catalyst. How do we actually go? When scientists rank catastrophic risks, they methodically list these very Hollywood-style threats. We've got engineered pathogens, or massive climate tipping points like the collapse of the Amok ocean current or the Amazon dieback. There's nuclear war, and actually it's the ensuing nuclear winter and global crop failure that's the real killer there, not just the initial blasts. We also have asteroid impacts, though to be fair, we actively track over 96% of large near-Earth objects today, so that's a pretty low probability. There's also the highly speculative and heavily debated risk of unfriendly AI. And finally, supervolcanic eruptions. Think of the Toba event about 74,000 years ago, which actually might have caused a severe bottleneck in early human populations.
Now, notice the stark contrast in scale between these threats. A single hydrogen bomb detonated over the U.S. could cause a catastrophic EMP, instantly crippling the grid and causing mass casualties in a matter of days. But when you zoom out and compare that against the deep time timeline of cosmic doomsdays, these loud, dramatic, explosive endings might actually be way less statistically pressing than a silent, ongoing shift that is happening right now.
Which brings us to a really fascinating concept from a recent paper on the Great Filter Hypothesis, exopopulation. Basically, this is a scenario, a filter, where an advanced species simply ceases to replace itself. There's no asteroid, there's no nuclear fire. The species just stops breeding because of shifting social, economic, or psychological values. It leads to this very quiet, almost benign extinction.
And here is the absolutely crucial data point for that. 2.2. That is the global total fertility rate, the average births per woman as of recent data. The human replacement threshold, just to keep the population stable, is 2.1. Once a population drops below that line, which, by the way, many advanced economies already have, depopulation doesn't just happen. It turns into an exponential decline.
To put some UN demographic math behind this, global births actually peaked back in 2012 at 146 million, and the trend has literally been moving downward ever since. So this quiet disappearance of humanity, it isn't just speculative science fiction, it is a real demographic trend, already in motion all across the globe.
Section 2. The immediate dark. Days to weeks without us.
Let's assume this quiet extinction runs its course, or maybe a superbug just abruptly clears the board. Our automated infrastructure immediately becomes a ticking clock. Without human supervisors there to monitor pressure drops or manually reset systems, a cascade of technological failure kicks off. Within just 48 hours, the diesel emergency generators keeping hospitals and data centers online, they burn right through their backup fuel. Give it 1 week, and most nuclear and hydroelectric plants will trip routine safety breakers that require an actual human hand to reset, which plunges our distribution networks into total darkness. And within a month, the complete lack of climate control invites moisture, mold, and rot to set into our buildings.
So, that state of perfect preservation we talked about at the start, it's just an illusion. Paint this picture in your mind. In the final electric moments of our major transit nodes, digital billboards will be looping bright advertisements to absolutely no one. Pedestrian lights will faithfully cycle from red to green, trying to manage a flow of human traffic that is permanently stopped. And they'll just keep doing that, right up until the grid dies completely.
Section 3. Nature reclaims the Earth. Years to decades.
Once our tech fails, the transition from a human-managed world to a wild one is incredibly rapid and honestly pretty violent. Within a year, every major urban center is pitch dark and totally silent. But that next decade, that's when it gets wild. Without firefighters around, megafires will rip unchecked across the planet, consuming unmaintained structures and forests in blazes we can barely fathom. By year 30, the rubber gaskets sealing skyscraper windows will dry out and fail. Imagine full-sized glass panes falling from residential towers, just shattering onto the empty streets below, while moisture, mold, and plant life aggressively move in to deeply destabilize all that concrete and steel.
But on a planetary scale, the Earth system, which we had stressed to some really dangerous tipping points during the Anthropocene, actually begins to regain its resilience. It fiercely reclaims those spaces we paved over, naturally buffering our past environmental impacts as native vegetation outsurvives invasive species in the ruins of our cities.
Section 4. Medium-term decay. The collapse of the modern world over centuries.
So how do our proudest, most massive engineering achievements actually fare against deep time? Well, the short answer is not very well. Without humans constantly painting and maintaining the steel struts, our modern suspension bridges will suffer from severe corrosion. Within just 100 years, those giant swaying cables will snap, collapsing spectacularly into the sea. By the 500-year mark, modern residential neighborhoods will be completely swallowed up, fully transitioning back into dense, wild forests. Ironically, the structures that will remain standing the longest are the ones built in the old ways, out of solid, simple stone.
It's a really fascinating contrast when you look at it. The fragile materials that make up our everyday lives, drywall, wood, paper, standard steel, glass, they decay incredibly rapidly. But what survives? Our terrestrial legacy is essentially going to be defined by the stubborn, the toxic, and the elemental. Bronze statues will endure perfectly. Thick plastics will eventually break down into microparticles, but they will absolutely persist. Ceramics will outlast almost all of our modern buildings. And of course, our radioactive waste will remain a quiet, highly hazardous footprint for millennia to come.
Section 5. Our deep time legacy. Thousands to millions of years.
When human lifetimes are replaced by, millions of years, our final erasure is methodical. First, our massive structures just crumble into ruins. Then, those ruins are slowly buried by natural shifting landscapes, advancing ice, rising soils, changing rivers. Finally, literally all of human achievement, our cities, our wars, the internet, our greatest art, it all gets compressed into a single thin geological layer. To a completely hypothetical geologist digging around millions of years from now, will be nothing more than a millimeter-thick stratum of rock that just happens to contain some really unusual concentrations of heavy metals and synthetic plastics.
Down here on Earth, perhaps only Mount Rushmore's carved granite faces will remain recognizable as biological forms for hundreds of thousands of years. But, ironically enough, our most permanent monuments won't actually be on this planet at all. The Pioneer plaques, the Voyager Golden Record, they'll be drifting silently out there in the interstellar void. Those, along with our fading radio waves traveling outward at the speed of light, will long outlast the Earth itself.
As our source material so aptly put it, the world wouldn't stop immediately, but it certainly wouldn't wait for us either. The Earth is entirely, completely indifferent to our absence. It's going to heal, it's going to adapt, and it's going to continue its cosmic journey through the solar system without skipping a single beat. Which leaves us with this final, really quiet, profound thought. If we are ultimately destined to become just a millimeter-thick layer in the bedrock of a planet that will eventually forget us entirely, what did our brief, brilliant spark actually mean? It's a powerful reminder to appreciate the sheer, immense scale of geologic time, the very delicate balance of our current planetary commons, and our highly temporary, deeply precious place within it. Thank you so much for joining me for this explainer. Keep wondering, keep learning, and I'll catch you in the next one.